Welcome back to another explainer. Today, we're tackling a seriously fascinating macroeconomic force that actually governs international trade and finance. We are going to build an economic map from the ground up to understand exactly how global economies maintain balance. So, let's dive right in with a pretty simple question. How on earth do countries balance their international checkbooks? Just like a household or a business, a nation has money coming in and money going out across its borders. When we're talking about this massive nationwide flow of cash, we're talking about the balance of payments. It's essentially the ultimate ledger of a country's economic interactions with the rest of the world. And understanding this is absolutely crucial because when this balance breaks, it can literally dictate whether a country's currency collapses or thrives. But how does a country keep that ledger perfectly balanced when millions of global transactions are happening every single second? To answer that, here is our roadmap. We'll meet the BP curve, compare the current and capital accounts, draw the curve, look at extremes of capital mobility, and finally, understand disequilibrium. All right, Section 1. Meet the BP curve, the ultimate balancing act. The very first thing you need to grasp here is the sheer power of the number zero. In an open economy, true, absolute equilibrium only happens when the sum of a country's international accounts equals exactly zero. Nothing left over, nothing missing. When the inflows perfectly match the outflows, the ledger zeroes out and the economy achieves balance of payments equilibrium. Which brings us to our definition. The BP curve, short for balance of payments equilibrium curve, represents all the possible combinations of a country's domestic interest rates, which we'll call I, and its national income levels, which is Y, that result in that perfect zero. Now, what's really interesting here is how this concept takes two massive, seemingly distinct macroeconomic forces, the interest rates set by central banks and the total income earned by a nation, and inextricably links them together. They are the coordinates on our economic map. Moving on to Section 2, current versus capital accounts, dueling forces. You can kind of think of these two accounts like a giant scale of justice. On one side, we have the current account, or CA. This account primarily tracks trade, and it leans heavily on national income. Why? As a nation's citizens get wealthier and their income rises, well, they naturally buy more imported goods from abroad. But buying more imports actually worsens the current account, pushing it toward a deficit. Then, on the exact opposite side of our scale, we have the capital account, the KA. This one tracks investment flows, and it primarily depends on domestic interest rates, I. As domestic interest rates rise, the country becomes a highly attractive place for foreign investors to park their money for a good return. This increases capital inflows, heavily improving the capital account. So the crucial takeaway is that for a country to maintain equilibrium, these two forces must perfectly cancel each other out. This mathematical harmony means the current account as a function of income plus the capital account as a function of interest rates absolutely must equal zero. If your rising income causes a trade deficit on one side, you need foreign capital rushing in on the other side to pay for it. Okay, let's hit Section 3, drawing the curve, a mapmaker's journey. Let's actually build this out like a mini story. Imagine we start at a perfectly happy equilibrium point. Let's call it y_0 and I_0. At this exact spot, the balance of payments is completely satisfied. But then, boom, the nation's economy takes off. Income increases to a new point, y_1. Because citizens are richer, they immediately start buying more foreign goods. Imports surge, which creates a trade deficit in the current account. The balance is broken. So how does the economy save the day? To restore the equilibrium and cover that new trade deficit, the central bank has to step in and raise the interest rate to a new, higher level, I_1. This higher rate acts like a giant magnet, attracting enough foreign capital inflows into the capital account to offset the exact amount of the trade deficit. When we connect our starting point to our new point, we get an upward sloping line. And this brilliantly illustrates why an increase in income must always be offset by a higher interest rate to maintain that perfect zero balance. Next up, Section 4, extremes of capital mobility, changing the slope. The slope of our BP curve is entirely dictated by the degree of capital mobility, basically how easily money can slosh across borders. Look at the first extreme, perfect capital mobility. Imagine a world with literally zero barriers to investment. In this scenario, the BP curve becomes completely horizontal. Why? Because the domestic interest rate is absolutely locked. It must exactly equal the world interest rate. Even a tiny change would cause an infinite flood of capital in or out. Now look at the complete opposite scenario. Perfect capital immobility. Imagine an economy entirely walled off from global finance, like a strictly isolated nation that outlaws foreign investment. Here, the BP curve becomes completely vertical. The equilibrium is now totally independent of the interest rate. You could raise domestic interest rates to the moon, and not a single dollar of foreign capital would enter. So the whole landscape of our graph is completely transformed depending on these rules of mobility.
All right, final section. Section 5. Understanding disequilibrium, wandering off the path.
See, the BP curve isn't just about balance. It acts as a strict boundary separating two very different economic realities. If a country finds itself in the top row of this matrix, any point above the BP curve, interest rates are actually higher than what's required for equilibrium. Because rates are so high, the country attracts much more foreign capital than necessary to cover its trade balance. The result? A balance of payments surplus. The capital inflows are vastly greater than the current account deficit. But if you wander below the BP curve, down into the bottom row, interest rates are simply too low to attract enough capital to cover the imports generated by the country's income level. You're buying goods from the world, but you aren't attracting the investment to actually pay for them. The result is a persistent balance of payments deficit. The trade deficit completely dominates whatever meager capital inflows exist.
Wandering off this path has some pretty intense real-world stakes. Let's say a country is operating above the BP curve in that surplus region. Money is just flooding in from foreign investors chasing those high interest rates. Under a fixed exchange rate system, this massive influx of foreign capital creates a powerful dynamic. It puts intense upward pressure on the value of the domestic currency. The central bank literally has to actively intervene just to keep the currency from skyrocketing in value. The excess capital essentially forces the currency's value upward against the boundaries of the system.
Which brings us to our final thought for this explainer. We just saw how the surplus zone forces a currency's value upward because capital is pouring in, but I want you to consider the flip side. If being above the curve forces a currency upward, what in the world happens to a country stuck in a perpetual deficit completely below the BP curve? What happens when a nation continuously imports more than it can afford and its interest rates are just too weak to attract the foreign cash needed to bail it out? That downward pressure on its currency and the subsequent drain on its central bank reserves, well, it carries severe consequences that can entirely reshape an economy. Keep that provocative thought in mind next time you look at global markets. Thanks so much for watching, and we'll see you in the next explainer.